let's start with x is less than 4. That's what this symbol means here. It means less than if we read it from left to right. X, which can take a value, is less than 4. I like to think of it as a crocodile. So there's some teeth, there's its eye, and the crocodile always eats the larger value or the higher value. So here, 4 is greater than our x, our variable. So we read this as x is less than 4. What could it be? What possible values could x take? Well, it could be 3, because 3 is less than 4. It could be a half. That's allowed, because a half is less than 4. It could be anything negative, for example, negative 100. It could be a decimal, for example, 1.8. There are lots and lots of possibilities. It cannot be 4, and it cannot be anything that's greater than 4, because x is less than 4. Let's have another one. Y is greater than 7. So y could be 8, for example. It could be 9. In fact, it could be 7.2, as long as it's greater than 7. And it could be 99.9. And this list goes on and on and on, as long as the value of y is greater than 7. Let's have a slightly different symbol. We'll go for W, and we'll write this symbol. Now with the extra line underneath, it means it can equal. So here we have W is less than or equal to 10. So 10 is included in this. So we could say 10 is the highest value that it can take, and everything else has to be less than that. So W could be 9. It could be 0 or negative 3 or 4/3. Anything you like, as long as it's less than or equal to 10. U, we'll say, is greater than or equal to negative 3. So let's think about this. The lowest value that you can take is negative 3. It can equal negative 3 because of this line here. And everything else is higher than that. It's greater than negative 3. For example, negative 2 or 1 or 5/4 or 8.6. The list goes on, as long as it is greater than or equal to negative 3. Let's think about one more thing you might see. We'll take the letter N, and we'll say that N is greater than 3 and less than or equal to 7. And to make this a little bit easier for us, we'll say that N isn't any number, it's an integer. What are the possible values of N? Well, we're not allowing decimals like this here or fractions like this, only integers this time. It has to be greater than 3, so it can't be 3. So the lowest number it can be, if it's an integer, is 4. 5 is allowed, because 5 is greater than 3 and it's less than or equal to 7. 6 is allowed, and 7 is allowed as well. These are the only numbers that we can have in this range if we're only allowing integers. 4, 5, 6 and 7. 7's allowed because it's less than or equal to N. Here we have some inequalities to solve, and we can use the same method that we use to solve equations to solve inequalities. Let's take the first one. 2x minus 1 is greater than 5. Well, if I add 1 to both sides of this inequality, I'll get 2x is greater than 6. And if I divide both sides of my inequality by 2, I'll get that x is greater than 3. So x can take any value as long as it's greater than 3, for example 4. Let's have a look at the second one. The second one has got this negative in it. 5 minus 3x is less than or equal to 1. Now you always want to avoid dividing by a negative. So the first thing I'm going to do is add 3x to both sides. So here I'll have 5, and here I'll have 1 plus 3x. Now I've got a positive variable. I feel much more comfortable with this. So I'm going to take 1 off both sides. There's 4, and there's 3x. And then I'm going to divide both sides by 3. So I've got 4/3 there, and I've got x there. This is a great top tip actually. Instead of leaving it as a decimal, leave it as a fraction. If you can't work out the division, leave it as a fraction. So this means that 4/3 is less than or equal to x. Or we could say that x is greater than or equal to 4/3. For example, x could be 4/3 or 5/3 or 6/3, which is 2. Let's look at this next one. Again, I'm going to solve this like I'd solve an equation. So 3x plus 1 is less than 2x plus 5. I'll start by subtracting 2x from both sides. So that'll leave me with x plus 1 on the left hand side and 5 on the right hand side. And then I'll subtract 1 from both sides. So x is less than 4. For example, x could be 3 in this one. And here's the last one I want to do. This is pushing it a little bit, but I feel like we can do it. So 2 lots of x squared minus 1 is greater than 17. I'll add 1 to both sides. 2x squared is greater than 18. And now I'll divide both sides by 2. So x squared is greater than 9. Well, this is the bit that's getting a bit tricky now, isn't it? What's the square root of 9? Well, we know that the square root of 9 is 3. But you might also know that if you do -3 by -3, you get a positive 9. So actually there are 2 solutions to this. The square root of 9 is 3 or -3. But we've still got to consider this with our inequality. So x is greater than 3 or x is less than -3. Now when you think about it, it makes sense because we want these values when we square it to be greater than 9. If we square, for example, something that's less than -3, let's take -4. If we square that, we get 16, and 16 is greater than 9. If we went for a number that was greater than -3, for example -2, and we squared that, we'd only get 4, and 4 isn't greater than 9. Now this is really advanced, so if you can get your head around this, you're doing really well.